Welcome back to another Rise Up, Don't Run Math video. In this video, we're going to take a look at some common types of angle pairs and their definitions. Then we're going to look at some examples of what this might look like in math class. Let's start by defining what is a complementary angle. A complementary angle adds, or complementary angles rather, add to 90 degrees. When you have complementary angles, they can sometimes be touching or share a ray. So let's say this is our two angles. Maybe one of these angles is 30 and the other is 60, and together they make 90. Or sometimes those angles can be completely separate from one another. This would be 60, this would be 30. They don't share any rays or sides, but they still add to 90. Another type of angle that's similar to this is called a supplementary angle. Supplementary angles add to 180 degrees. And just like when they're complementary, supplementary angles can share a ray. So for instance, maybe this is 70 and this is 110 degrees. Or maybe they're completely separate. Maybe this is 110 here. And then somewhere else we have a ray or an angle that measures 70 degrees. The next type of angle that we're going to look at is called adjacent angles. Adjacent angles are angles that share a ray. You saw that in both of the previous examples I drew. When we have adjacent angles, those angles are next to each other. So this could be one angle, this would be my other angle. And this line down the middle, or this ray down the middle rather, is the ray that they share. So adjacent, in kind of simpler terms, means next to. They're next to each other. A linear pair is a special type of angle pair. A linear pair is both supplementary and adjacent, meaning our angles add to 180 and they're next to each other and share a ray. We actually already looked at an example of that below. If this was our angle and this measured 100 and this measured 80, these two would be a linear pair. They're called a linear pair because a straight line or straight angle like this is 180 degrees. Since there are two angles forming that 180 degrees, we call them a linear pair. The last common type of angles that you'll see are called vertical angles. I'm going to draw vertical angles first, and then we'll talk about their unique property. Vertical angles are formed when two lines cross one another. They are the angles that are opposite of each other in the X shape that was just formed. So the two black angles here would be vertical, and the two pink angles would be vertical. The unique thing about vertical angles is that their measures are equal. One way to think about this is vertical angles can be formed by just doing a rotation. If we think about rotating this 180 degrees, it would land on this angle here. Let's now go ahead and look at some examples of what this might look like in a geometry class. In example 1, it says find the missing angle measures. Before we begin setting up our equation, let's look for different types of angle pairs in our picture. The first angle pair you may notice, or an angle pair you may notice, are the vertical angles that we have across from each other. So we have those two, and we have these two. As we said above, vertical angles have equal measures. You may be inclined to set up the equation 5x minus 15 equals y. However, based on our current information, this doesn't really help us because we have a two-variable equation and can go no further. That means we need to find x or y first. Let's look for another type of angle pair. The other type of angle pair you may or may not have noticed is the linear pair. The linear pair is formed between the pink and the yellow angles. This is our linear pair. They form a straight line together. Linear pairs, if you don't remember, both add to 180 and are next to each other or adjacent. We can use this relationship to set up an equation. Y plus 90 has to equal 180. When we subtract 90 from each side, we get y equal to 90. I'm going to write that on my diagram so I can visualize what's going on here. Now to find x, I can see that the angle across from it measures 90, so 5x minus 15 must also equal 90. And now we can solve for x. I'm going to add 15 to each side, and I get 5x equals 105. Next, when I divide by 5, this makes 1, and I get 1x, or x, equals 105 divided by 5 is 21. So now I have found the two missing values in our problem. Using vertical angles, which were across from each other, the pink were vertical and the yellow were vertical, and linear pairs, which are next to each other on this straight line. Let's take a look at one more example. Example 2 says an angle is 9 times larger than its complement. What is the measure of the complement? Anytime in geometry they give you a description of a picture, you should start by drawing that picture. If it's telling me that I have two angles and there is a complement, that means that the two angles are going to measure 90 degrees. I'm going to choose to draw my picture where the 90 degrees is shared. So here is my 90 degree, and I'm trying to find my two angles. One of the things it tells us is that an angle is 9 times larger than its complement. So what that means is that if you have an angle, let's say that we have this angle x, this angle would be its complement. So an angle x is 9 times larger than its complementary angle. So to make these equal, I would say 9 times c is equal to x. Because x is 9 times bigger, I would have to multiply c by 9. And then it says, what is the measure of its complement? So if x is equal to 9c, I'm going to write that here. So now I could write an equation to find the value of c, because I know that 9c plus its complement should be equal to 90 degrees. 9c plus c gives me 10c. When I divide both sides by 10, I get c is equal to 9. So on our diagram, c equals 9 degrees. To find x, I would do 9 times 9, which is 81 degrees. So the question asked, what is the measure of its complement? So an angle is 9 times larger than its complement. So the complement is the one that we called c at the beginning. So c equals 9 degrees. The trickiest part about these problems is just the wording. Drawing a picture always helps. I hope this video has helped you understand some common geometric vocabulary and how these problems might turn up in geometry or algebra class. Thanks for tuning in.